Hi friends, in our last session, we have seen our topic that was interoperability in a smart automation and enhancing resilience in a factory. In today's session, we are going to the new topic that is communication and networking of industrial Internet of Things. This is Fazan Kagvi and I welcome you all to a lecture series of industrial Internet of Things. So let's begin with our topic. Now, as we know that IoT, that is Industrial Internet of Things, which has been recently emerged, aims at connecting all the sorts of everyday devices to the internet, such as we can say air conditioner, washing machine, television, refrigerator. So these all the components are required to be connected to the internet, right? So these are our day-to-day appliances which we have to use and which has to be accessed from anywhere. Okay. So before that, we need a internet connection infrastructure requirement is there. Okay. So we can say that IoT is going to enable new ways of interaction and automation. Also, we know that IoT has been exploiting the new potentials, right, in the field of developing the new products in the industry, right, which makes their service remotely accessible to the humans as well as to the other devices. Okay. Now this field that is IoT is constantly focusing on improving the day-to-day life of our humans. Okay. So how we can do that? So by providing a remote accessibility, right? By providing the interconnection of with the interconnection of a various devices, interconnection of a services and tangible interactions. Right. Now, we can say that our IIoT, that is Industrial Internet of Things, is loosely coupled sub-area of IoT, that is in the Internet of Things. So, this focuses on what? We can say that it focuses, as the name itself suggests, that is industries, right? That is manufacturing process. Okay. So, in a industrial automation, for achieving the industrial automation. So, that is adding values to it by globally connecting machine parts, production entities, and factories. So this is the aim of our IIoT. Okay. Now, similar to IoT, we can say that IIoT builds upon the premise that globally accessible communication infrastructure is available to the plenty of devices, to the number of devices which are involved in the industrial process. Right. So obviously that this is going to require what? It is going to require the advanced technologies, right? Wireless technologies, which are going to provide a connection to the production system and will introduce the high flexibility to our industrial processes, right? So what are the benefits by doing so? We can say that this is significantly going to reduce the cost for deployment and maintenance, as we can say the cables which we are using previously. At present, we know that for internet connection, optical fibers are most preferred, right? Previously, we were using the local cables, right? So the connectivity and latency, that is a transfer of data, was quite limited, or the speed was quite limited. But by using optical fiber, we can achieve a higher speed, right? So these are the technological advancement in this field. Okay. Now, as a cable are negatively affected by wear and tear, we also know, and exposure of these cables to the harsh and industrial environment also requires the need of wireless communication or wireless networking. Right. Now, we can say that this topic is going to focus mainly that what we are going to study in this topic is that existing communication technologies are which one? Okay, which are the existing technologies? Then after how they may be adapted in our industrial internet of things, and we are going to also address and see some of the unique challenges for implementing the industrial internet of things. Okay, so let us begin and see the next slide. Now we have to see communication in industrial automation. Okay, so as you can see, a diagram is shown over here. So this figure is representing a data flow in a wireless industrial network. That is, first S represents the sensor, C represents the controller, and A represents the actuator. So we all know that the function of sensor is to receive all the signals from the actual devices, operating devices. That signals are given to the controllers, right? Now controller is going to give a command. It is going to provide the processing data to the actuators. Actuators are the one which are going to take actions, right? So you can clearly see it is written, sensors periodically send the measurements to the controllers, which after processing the data, which after converting the data in a machine language, sends the commands to the actuators. Okay. Now let us see these three distinct components in detail, that is sensors, controllers and actuators, and their responsibilities are also defined in this paragraph. So first you can see the term is sensors. Now what we can say, sensors are going to continuously or periodically measure the target parameters in their respective environment, in their respective vicinities. That is, it is going to measure the response of the various devices. Okay, and based on the response received, that is the output values are either provided regularly with a certain interval or event based. Okay, so these responses has to be filtered, these responses have to be verified, and then that is going to be provided to the controller. So when a predefined threshold is exceeded, the unfiltered output values are typically conveyed to the controller. Our next term is controller. Now what's the function of controller? So controller is going to continuously receive measurements from a sensor as an input. Okay. Now the measurement which are received are stored within a controller. So as we know that controller is going to have a memory. Okay. So in that memory it is going to store the data which is received from a sensor, and also various models are, that is mathematical models are also present in a controller which is going to verify, or which is going to verify the conditions whether to switch on or whether to switch off the actuators, right? So this is the example that how a programming will be present in a controller. Okay, after doing a calculation, that is after doing a processing, the controller is going to give the commands to the actuator. Okay, so the continuously feed into a control function mapping the measurements to the output value. Okay, so example using a differential equations, that is mathematical model, right, as I told. Okay, so this output value is then sent as a command to one or more actuators. So remember that the overview of a controller is to receive the signals from a sensor, then store the data of a sensor, process the data, that is by using a various equations or a mathematical model which are present in the programming of a controller, in a memory of a controller. All the data will be processed, calculated, and then based on an output or a solution obtained by a controller, the command will be given to the actuators. Okay, now next term is an actuator. You can clearly see that actuator is going to act based on a command provided by the controller. Okay, so the possible actions are what? So we can say the actions which an actuator can take is, for example, moving a machine parts to a certain position, right? Okay, then changing the rotational speed of a engine shaft, that is our RPM, varying the RPM of an engine shaft, then performing an emergency stop. So all these tasks are performed by the actuators. Actuators thus directly influence the environment in which they are going to operate. Okay. Now there is a society that is called ISA, Instrumentation System and Automation Society. Basically, it is a working group which defines the 6 different application classes for industrial automation involving sensors, actuators, and controllers, which can be categorized in a 3 groups. So you can see a monitoring applications will be the one that is called a class 4 and 5, which is shown in the next table. Okay, in the next slide. Then control applications will be there, which is a class from 1, 2, and 3. Okay, are shown in the middle of the table, and safety applications, that is a class 0, which is shown in the top side of a table. So let's see the table of this 6 different applications defined by ISA, that is Instrumentation System and Automation Society. So you can clearly see the overview, the table has been shown. First column is of a category, second column is of a class, third is of an application, and fourth one is for a description. Okay. First is a safety category, which is a class 0. Now the application of this category is a emergency action which has to be taken. Okay, so obviously whenever emergency action has to be taken, the condition will be a very critical condition. So always this action will be a critical action. Okay. Second is a control category, in which there is a 3 class: class 1, class 2, and class 3. Class 1 has an application of closed loop regulatory control. Okay, so closed loop regulatory control, which means we know control that is a function of a controller. So this is an application which are based within a controller. Okay, so this first class has a critical application. Then after second, class 2, that is the closed loop supervisory control. So this application is basically not very critical. And class 3, that is a open loop control in which a human will be present. Why? Because it is an open loop. Human dependency will be there in case of a machine operating. Okay, so human is in a loop. Okay. And the last category is a monitoring category in which there are two class 4 and class 5. So class 4 has an application of alerting. Okay, that is whenever some problem comes or whenever some action has to be taken, alerting will be the application of a monitoring. Okay, that is done by that. And the description is that short-term operational consequences will be notified. Okay, then class 5, which is a logging and downloading or uploading. So this application is the one in which no immediate or on the spot action has to be taken, operational has to be taken. So obviously we can say from this table that when a user class is more critical, that is in our case 1 class 0, so that is our safety, right? Emergency action. So in that case performance requirement is much higher. Okay, that means a single device being used for class 1 application will need a more network resources and high priority access to the internet than the another single device which is used for class 5, that is for downloading or uploading purpose. So it is anticipated that there will be a more device used for monitoring and controlling. Potentially tens of thousands of devices will be present in our factories. Okay. Now in current automation system, we can say controller is implemented separately from the sensors and actuators, and centrally it is going to collect all the data from the sensor controlling a different actuators. For example, programmable logic controller is one of the type of a controller, right? So this indicates that considered components must be connected via communication system. This represents the need of a communication system to be able to exchange the data. Okay, so we can say that some application classes out of the 6 applications requires a strict or precise data, that is stringent communication data which is required, and it has to guarantee that data for a proper function of this class. Okay, so this indicates that for example safety applications which is a class 0, small data packets must be transmitted with a high reliability and it must guarantee the low latency. Now what is latency? So latency is basically a time taken for transmitting a data from original source to the required source. So obviously that lesser is the time taken, that is faster with the data transmission, right? So lower latency is the requirement. Okay, much lower latency is required. So that is what it is mentioned, that class 0 will require a high reliability and a low latency. Okay. Now critical closed loop, which you can see is a control category representing class 1, 2 and 3. So critically closed loop control imposes a stringent guarantees on the reliability and the latency. So these applications will require adapted communication systems that are able to provide the needed guarantees. Okay, now let's move on and see the challenges which we are going to face for industrial Internet of Things. So each component introduces its specific challenges that must be considered to achieve a coherent and flexible solution. Okay, so let us see what are the challenges they introduce. So we can say that local automation cells, which are the area basically in a factory home. Okay, so what it is going to include? So it includes the sensors, actuators, and a controllers. These are going to be operated within this local automation cell. So it is obviously required that all these devices must be interconnected to each other via communication system. Okay, that system would be either a wireless link. So these wireless links are more preferred. Why? Because of the flexibility and it reduces the maintenance cost. Okay. Furthermore, safety applications and a critical closed loop control, which we have seen in a previous slide, also imposes a strict communication which should be mainly addressed on a physical and on a data link layers. Okay, so due to the broadcast nature of a wireless medium, these devices within the same automation cell are in most of the cases able to directly communicate with each other. Okay. Now next is a factory holes. The challenges which we face with the factory holes consist of a several automation cells. Okay. Now each cell has a specific task to perform and a responsibility. Okay. So on a factory hole level, these cells must be interconnected with each other in order to achieve the coordination and adaptability for the automation within a factory. Okay, now what it will require? So this requires a device to have a unique address at least on the factory hall level. Okay, each cell must have a unique address. Okay, so additionally, the communication system must provide routing to connect the device to a plant controller and allow for information exchange between the devices in a distinct cells, that is in a different automation cells. Now furthermore, one or more gateway within a factory may provide accessibility to the internet and will allow for inter-factory connection. So the supported application classes on a factory whole level and beyond usually includes class 2 application and above. Okay, remember that we have seen in our table 1. Okay, now let's move on and see the next. Now application layer communication. So it is going to enable access to industrial Internet of Things services, for example, to synchronize the production process across the factories and to adapt the process via cloud computing. Now the main challenge in this context are very much similar to the IoT, that is efficiently connecting constrained devices to the internet with a standardized solution. Okay guys, so with this we are completing with our today's session. In the next session we will start with our next chapter, that is modeling of cyber manufacturing system and IIoT. So till then stay tuned and